All right. Yeah. So, like I said, oops, yeah, I'm on, go, I put myself in a meeting. Yeah. So today, we got questions and stuff like that, just like every office hours and stuff. I'm going to specifically kind of talk a little bit about, like Kaggle kernels and Google Colab, which are kind of like the intermediary between like using your local machine and like a full-fledged like server, which I think is kind of useful for a lot of little projects and stuff. And both Colab and kernel are free. I should say now Google Colab you can pay, right, for a pro subscription, but you don't have to. So I'm going to go through that. And Albert was kind of just mentioning about like, having server space. This is a kind of like sometimes a good option just for like, oh, I just need to run some projects and stuff like that where I don't want to pay for a server and stuff like that can be good. But for the record, if you are looking to do a server, like AWS is the kind of like the standard, like oh, what to go into. But there are definitely some other options out there. One thing I like to recommend on it, just because their AWS's competitor, Google Cloud Platform, if you sign up with a Google Cloud Platform, you get $300, at least as of right now, $300 credit for the first year. So basically, if you up to basically for the first year, you have $300 to spend. And then after that year, it goes away. But in general, it's like, oh, that's perfectly good. And I'll kind of give a little secret. It's like making a Google account is free. So you could basically keep making Google accounts if you really wanted to. And that's one way you can get stuff, especially if you're kind of like tight on a budget and stuff like that. But in general, like I kind of recommend when people are trying to do different, like trying to do different projects using something like Colab or Kaggle kernels, it's usually good enough because you just need to run it in that one instance or a few instances before. Okay. But before we get into that, then I guess I should go and share my screen and then we can kind of go into any questions you guys might have. So as I'm pulling up my screen, does anyone have any questions? I didn't see anything in the doc, so I'm open to anything you guys might want to talk about.
I just have a question. It's kind of random, but what is Snowflake? Like, is Snowflake just like cloud data storage, or what is it? Because I know that that's been like, they had their IPO, there's been a lot of buzz about it. Have you heard? Like, what is Snowflake?
Yeah, so Snowflake, you'll actually see sometimes job descriptions ask like, it's like, oh, like have you used Snowflake before? Basically, you can kind of think of it as like, how do I say this? The data acquisition side of your data science part, but it does so much more than that. So this is going to be more on the data engineering side, which we didn't go into full details about, but like, for example, I just pulled up their website here, right? Data engineering, data lake, data warehouse. When we talk about that kind of stuff, it basically is the way you can store that and actually process it. So it used to be like, oh, we talk about database systems, like places you can put your data. That line is getting blurred now with like what you can do, like with data science, for example. Really typical examples like AutoML. Like AutoML is like usually associated with some kind of data stuff, but you can actually use as kind of like their service on your data, like automated machine learning as well. That's kind of what Snowflake is about. But if you're wondering, like, oh, this is something I need to like know, or like, do I have to have experience in this? Like, I wouldn't necessarily say that. I'd say, some companies will use Snowflake explicitly, others won't, and stuff like this. If you're looking for like a small project for yourself, I wouldn't worry about using something like this. But if you do see that kind of description on there, I wouldn't worry about like, oh, I need to learn this specific thing, otherwise I'm not going to be able to compete in the market. Again, it's kind of like knowing the basics of data engineering, which I think is like when we talk about that section back in, I can't remember what section it was, but when you talk about like data engineering in general, like understanding what processes there are and stuff like this. For the record, if you hear data lake versus data warehouse, does anyone know the difference between that too, or have they heard that before? Okay, main thing is data warehouse, you can kind of think of as like, I call it like old school, but it's like it's used a lot and it's actually really powerful. But a data warehouse is basically, think of like a bunch of tabular data. So you have many databases in it and you can kind of search through that. There's different ways you can structure a data warehouse, whether it's SQL, NoSQL, and all that stuff. Data lakes are a little bit different, and those are almost explicitly, I could be wrong on this. I'm thinking of an instance right now, but almost all NoSQL. And data lake is kind of like the idea of like a data warehouse that you can imagine like very structured and like putting like things on the shelf. A lake is like just throw the data in there, just throw it all in there.
Yeah, data lake is like, especially with log information and stuff, where you have logs from all over the place, and all of it is really unstructured. Like if you've ever seen different logs from different systems, they could be structured totally different than, you know, and so a data lake deals really good with stuff that's not structured.
Exactly, and that's the key word. It's unstructured data. Typically, like you said, like log data, but it could also be just like images, videos, and stuff like that. A really famous one that you'll hear a lot of is S3, S3 buckets. Basically, those could be treated like a data lake, where basically you're just pouring stuff in, and it's just like, it almost feels kind of like I don't know if you remember back when people talked about like polluting lakes and stuff like that, like just dumping pollution in there. It's kind of like that's how I imagine it. The funny thing is that I would say data warehouse was kind of like with the like we had this data warehouse, and then data lakes became more of like, oh, how really cool and everything. And we're seeing more than this, at least I'm seeing this more, industry moving back towards like, you know what, data warehouses are pretty nice and easy to work with. Because a lot of times what will happen is that you'll just have all this data, but then like you have to process it. Like, what do you do with this data? And that can take a lot of work and stuff like that. So a lot of times data lakes will kind of get into a warehouse structure just to make it work. Yeah, note that you'll kind of see things like this, like Snowflake and stuff, but it's not like any one particular like difference from like just data engineering in general. If you're curious about this stuff, you know, there's a whole, like, I will tell you right now, it's like, we could have a whole program dedicated just to data engineering. Like that is, it's a whole other beast. So the good thing is that you can probably just know the basics of data engineering, and then especially going into your first entry level position, right? Your first position coming out of graduating, you probably don't have to worry too much about saying, oh, I need to know specifically how to use, or I've had experience you doing something with big data or intense data engineering. You'll probably learn that specifically to your job. And then I would say after your job of like 2 to 3+ years, that's when you'd want to start looking like, okay, like how can I expand out my skills? And you'll probably know better at that 2-year mark of like what direction you want to go in data science. Do you want to start going more into the data engineering side? Maybe that's something that's interesting to you. It could also be the opposite direction. Like, oh, maybe you want to go more into like, you know, machine learning. You might hear now people talk about ML ops, like DevOps, which is kind of like what operations you need to do for machine learning and stuff like that. That's kind of becoming a more common thing where basically it's like, oh, it's like the deployment of machine learning, which is closer to a software engineer. And then I would say almost like the pure data science like structure, you might look more for analysis. Like they're now kind of, I have a feeling that data science, the position data science, is going to like evolve into different terms because data science is just such a huge area. And so the good thing is that you guys are in the beginning, like really in these early stages where it hasn't been completely defined yet. So you're going to be a lot more flexible and be able to kind of find your niche and kind of see like, you know, what makes the most sense. But anyway, that's Snowflake. I won't worry too much about it unless you were something specific you want to ask about it, Jessica.
That's it. I was just curious because like, yeah, they had their IPO recently and there was a lot of buzz. And so I was just, I actually hadn't heard of it before. And so I was curious about it. So thank you.
Yeah, no
totally answered my question.
Yeah, good. You'll hear a lot about the, like, I would say companies like this, like Snowflake, where they're kind of doing many different parts of it. And the idea is that, you know, they are hiring, like Snowflake does hire data scientists, for example, for their system, is they want to kind of build up tools that like, you don't have to give, like you can give to a non-data scientist and have them be used and useful. This is where like, this is where I think people get like freaked out, like, oh, like, is data science going to go away? Are we going to be automated away? And I say, no, like what's going to happen is that things in general, at least in my opinion, is that we're seeing things more like things are being automated, which means that we're just going to be focusing more on specific tasks and stuff like that. So everything you get, for the record, everything you guys are learning, I think is completely relevant. It's going to be relevant, especially if you guys, I would say if you wait like 5 years, then yeah, maybe that's when like things are going to start getting like, oh, you're going to be like, oh, you know the basics, but like there's so much more to know. But if you guys are getting into the next year, you guys are going to be fine.
I think the key is just keeping up with all of the new algorithms that come out. Right?
Yeah, it's I have conflicting feelings on exactly that, if that makes sense. I think it's important, and also as kind of more of a mathy person who likes that kind of stuff, I think it's like good to actually follow it. But I also look at it and be like, a lot of it ends up being much more how to use the technologies on there. Like, do you need to know the specifics of how every algorithm works? It's like, in reality, probably not. Like, and I think that's sometimes a little scandalous to say to people who are in data science right now. But usually the people who are in data science, who've been around for like, let's say 5+ years, tend to be people who've already were very academic focused, where they tend to be more, like the math side of things and stuff like that, or some kind of essence of math. So, but I think for most data scientists in the field that you talk to them, it's like, for example, let's say like, do you really need to know this? Like, yeah, like it helps, but not necessary. But I think keeping up with like what's being used is going to be, like you said,
Yeah, that's exactly what I meant. Because there are a whole lot of other algorithms out there that are pretty new and are just really taking off. Graph convolutional networks, anything having to do with graphs, actually.
Yeah,
Graph,
there's some interesting things you can do for sure.
Right, graph databases, all of that. So anything having to do with graphs, but yeah, there's a whole bunch of other algorithms, let's say other tools that are available that you should have in your toolbox, I would say.
Yeah, I think one thing I will say is that I'm noticing that this is me personally, I think is going to be a bigger deal, is things like differential privacy, federated learning. These things, I don't know if you guys I might have mentioned this very briefly at some points, right? But differential privacy is the concept of like, how do you, like, when we collect data as data scientists, you guys have seen, you can see a whole bunch of information. Like, as one person, you can see all this. I used to work with a credit union, and, for example, I would see everyone's social security number, which is kind of like, like that's actually really common practice in the banking and financial industry, where you just have these numbers exposed. You can imagine that, like, especially like as you guys are data scientists, you kind of know, like, it's like, oh, like that might not necessarily be the safest way to kind of pass data along. Like, well, but data is still really useful. How do we do something useful with this information without leaking out information to everyone else? And one of the strategies is something called differential privacy. I don't know, did I talk about this before? Give me a thumbs up if I something. Okay, I see some handshake. I saw Mike kind of give a little head nod. I might have mentioned it a little bit. But if you're curious, I think that's something that's going to be more and more common, and we're seeing, like, I'm seeing libraries and packages being implemented in different new versions for differential privacy. But to just really quickly, like, a summary, like, what does this mean? Basically, it's trying to keep things private without leaking information. Turns out the census 2020 is being done with differential privacy. For the first time, the census is actually being done with differential privacy, which is really more of an algorithm. But the main concept is kind of like, if you imagine going into like a room of like people, like there's a bunch of people in there, and what you want to do as like a data scientist is you want to know, how much money do people have in their wallets, just because, whatever reason, right? And if you go up to you could go to each person and say, okay, how much money do you have in your wallet? And you can say like, oh, I promise I won't tell anyone. This information is not going to go out to anyone. But like most people would be like, I don't really want to share how much money is in my wallet. That's kind of personal information that I really like. Sure, I might trust you, but like, what if you lose the paper, or, like all this good stuff? So it's kind of an issue, right? Because you kind of want to know about the room and how things are going. So what you can do is, and this is what the concept of differential privacy goes, is like you go up to each person and say, okay, like I want to know how much money's in your wallet, but before you tell me, I want you to look in your wallet, and then I'm going to have you roll like a die. And then whatever die roll you roll, let's say you roll a 5, right? Just add that to how much money you have in your wallet. So the idea there is, if you had $10 and you rolled like a 5, right, which is randomly chosen, you would say, oh, I have $15 in my wallet. Now, when I write that down, I know that it's likely that that's not actually the exact number that you have. But because I can do that with everyone, I know also that if I do this to every single person with a die roll, I know what the distribution of that random generated number. So I can actually understand a little bit. It's like, okay, I can subtract off essentially that randomness and know collectively how much, people have on average, plus, the standard deviation and all that good stuff. But I don't need to know any specific person's information anymore. That's the concept of differential privacy. Yeah, Jessica.
Then is that kind of following like the central limit theorem?
Kind of. It's kind of related to it. It's a little more involved than what I just described, because one of the things is there's talks about how much privacy can you leak? Like, for example, if I make this fuzziness, right, but like I start aggregating the data and say, okay, people who are women who are this age with this amount of money in their wallet, I can kind of like collectively understand like, oh, well, there's only so many people with these attributes, and then I can pull that information out. So differential privacy literally tries to measure how much privacy are you leaking out towards that. But yeah, in that case, it would kind of similar to like the central limit of like essentially random numbers, right? For the record, I actually think there's a really great video that talks about differential privacy in terms of, well, they talk about differential privacy, but they talk about it in the saying like how it's going to be used for the census. I don't know, has anyone seen minute physics before?
You know, now that we're talking about it, I feel like a while back, I do remember you giving the wallet example.
Mm-hmm.
So I don't know if we talked about that a long time ago, but
yeah,
I don't, this is the first time hearing about with the census.
Yeah, I sent it on the Zoom chat right now on this video. But yeah, they actually did it with the 2020 census. It's pretty cool. Differential privacy is one aspect, which again, like it's a solution to say, hey, how can we do data science and other data related things, well, basically data science, without leaking information. Another associated with this is something called federated learning. Has anyone heard me say this before, federated learning? Okay, I see a nod from Avero, but maybe some other, was like, not really sure. Federated learning, let's see here. Yeah, good. Google actually made a little, I want to say they made a little blog post, like a whole little interactive thing a while back. I'm gonna see if I can find it really quickly. But let's see, Google comic, that's what we want. I actually think they did a really good job explaining like, oh, federated learning. Like it seems like a little corny, but I'll kind of share this out too. But the main idea with federated learning here, which I think they do a great job explaining it, is that, again, like if you want to train a machine learning model, like the ideal thing is like you want all that data, right? And then train on it. But the problem is like, not everyone, you have to pass that data into somewhere, right? Like if you have a central server, and again, this kind of comes to the idea of me going around the room asking, saying, hey, tell me about how much money you have in your wallet. Like you might trust me because you're like, oh, Victor's not going to tell anyone. But like, you're like, what if someone's overhearing it? What if Victor loses that information? Like there's some reasons why you might not want to pass all that information that's very personal to even someone you trust, right? So federated learning, the idea there is basically federated, meaning kind of like separated out, is that you can train essentially models separately off of the main server, like a main central hub. And essentially what you do is you have each individual like small bit like train their own little model, and then collectively put those models together to make one decent model, and then kind of divvy that out to basically have the most like without basically keeping the data on the device. Like, okay, like phones is a good example of this, is that you can keep the data on the phone, train it on that phone, and then collectively send up this models that each phone does, figure out how well these models work, have a better model, and send it back down to everyone else. So what's kind of cool is that an example of this is like predicted text. So if you ever have like an Android phone, or iOS is the same thing. If you use Google Keyboard, for example, they actually use federated learning on this. And when you start typing a word, it's like, what's the next word that's going to be, right? Well, ideally, or what we have been doing is just sending all that information up to the, to a central server. They see whatever you type, and they get an idea of like, what's the next best word to do it. They train this model, and then they send this down to everyone's keyboard so they can predict it. The problem is that like, well, now you just gave information to someone else. Like, it's like, maybe you don't want people to know exactly what you type. Like that's kind of maybe some personal information you don't want to share. So the idea there is that you actually can do your, it will do the training a little bit on the phone itself, have a basic model, and then collectively with all these models be sent up to the cloud, essentially to a central server, which is essentially not the actual data itself, train this together, and then send out this ideal model. This little comic.
Sounds like segregated ensemble.
Yeah, it kind of is. It's kind of like it's a little, it's a pretty cool concept. So this is a big deal, like about how this can work. It's kind of like segregation, like you said, like, it's almost like an ensemble, yeah. But anyway, this comic does a really good job, I think, of actually explaining it, and it's kind of like a cutesy thing where like you can kind of like, it's it doesn't go into any math specifics and stuff like that, but I think you guys know enough about machine learning that you guys would understand like a little bit like, oh, how this would look like, which is pretty cool. So there's this guy too. So this is another privacy thing. One recent thing, which I love talking to people about, is COVID contact tracing, right? I'm sure you guys have heard about doing this. Now, traditional contact tracing, right? Not Contra Costa, that's where I live. Contact tracing. There is basically the idea is that if you get sick with COVID, someone can come up to you and say, okay, like, where have you been? You know, who have you interacted with? So they can kind of figure out who might else be exposed and figure that out. Obviously, this can be really difficult and actually really expensive too, having a literal person try to figure out where you've been. And then honestly, you don't remember, especially with asymptomatic symptoms, right? Or not, no symptoms, right? Is that you don't know exactly, you weren't really paying attention because you weren't feeling sick and all that stuff. So it's like, okay, what does that look like? So I don't know if you guys heard this in the news about like Google and Apple teaming up together. This is a while ago, coming up with it. Basically, they call it an app, but it's not really an app. It's basically more of a protocol of what this would look like for contact tracing. And I think there's a couple good, I have to search for a little bit better, but there's actually a good explanation of this, like what this looks like. And this again is like coming with the idea, it's like, hey, we want data, but we don't also want to expose people's information like to other people. Like again, like it's like maybe you do trust Google, maybe you do trust Apple, you know, doing the right thing, but like what if it, you know, comes up, you know, where this information gets leaked out? And the way they do this is actually super, super smart, I think. And it actually, I think is a good, you can see this compromise of like how much data do you leak out? Well, not leak out, but how much data you expose and how much information you can get. So I don't know if anyone's heard the whole algorithm, like how this works, but it's being implemented and being tested out, especially in the United States. And ironically, all the places that are kind of like saying, oh no, we don't want to use a system, it's because they want things that are less private, which is kind of a weird thing to kind of hear. But the idea here is that you have, you know, people have this on their phone. Essentially, it's a Bluetooth protocol. And essentially, while the phone's just sitting there, essentially it kind of broadcasts on Bluetooth, which is pretty low energy. But basically the idea is like it broadcasts a specific number. It's like a random number, basically, that's identified to you specifically. And it just broadcasts that for 10 minutes. And then other phones listen for any numbers that come in through this protocol. So for example, I'm just saying, you know, like my name, like my number is 82, obviously it's a bigger number than that, but it's like 82, 82, 82, 82. And then any phone's coming by, it's like, oh, I heard 82, you know, and it keeps going through. And basically the phones that walk by keep a list of any numbers that they hear that for a certain period of time. I think it's like a 10-minute period. So the idea is like, if you're hanging a conversation or sitting next to someone on the bus for like 10 minutes, you know, that would be like, hey, you've potentially been exposed, versus like just passing by one time. So if you hear these numbers, the same number over 10 minutes, like, okay, let me write this number down. The phone essentially writes it down in its memory. And then it keeps this list, right? And then let's say the person who came by, in this case, they said like Bob. Bob later on finds out he tests positive for COVID, right? And so the idea is like, oh, you might have been infectious for the past, like, you know, I don't know, like 14 days or whatever. It then basically says, okay, sends up to a central server. It's like, hey, this, because, sorry, I'm kind of jumping all over the place, but like Bob says, oh, I had COVID, and it's going to send now to the server basically what numbers he sent out to everyone to hear for. So the good thing about this too is that Bob's numbers cycle through randomly, well, pseudo-randomly. So like for 10 minutes, he's going to say 82, 82, 82. And then the next 10 minutes, he's going to say like, you know, 94, you know, and just saying 94, 94, 94. And he sends this list of numbers that he's been broadcasting for the past 2 weeks up to the central server. And then someone like Alice, who doesn't have COVID, but might have been exposed, Alice's phone, the app, the protocol, downloads these lists of numbers and says, hey, like I did have a couple matches from here. Like, oh, it looks like I was exposed to, I don't know who it is, but there was some person who has COVID that has been exposed to this. And they can say, oh, you possibly been exposed now. And so in a lot of ways, what's nice about this is that you don't have unique information by that person because it's randomly changing. It's actually very difficult to actually get this information out. It's called a hash. But basically, these numbers can't be really tied to that person. And when you can actually inform other people about saying, oh, you've possibly been exposed, but never actually saying who it is exactly. Which again, the idea there's like you actually have less information, right? It would like ideally, like as let's say you get this notification on your phone, like, oh, I've been exposed. Like when did I get exposed? It doesn't tell you when. It says, hey, get exposed. you might want to say, hey, I want to know, like, where was I? Like, all this stuff. And that's where actually, you do lose some information, but at least now you know that you've possibly been exposed. They might even say a date or something like that, depending on how the protocol is done.
So you don't actually, you don't, nobody looks for you to contact you and say, hey, you've been exposed. You basically, when you get that information on your phone, it'll tell you, hey, you've been exposed.
That's
Just
right.
by the numbers that you were exposed to, but nobody's contacting you. Then it would be up to you basically to say, hey, my phone said I was exposed.
That's right. And then the idea would be the next part would be someone else goes in. Now, obviously there's some drawbacks to this, right? Like one thing is that like, it's kind of like equivalent saying, it's like as if putting a public billboard saying, oh, Victor had COVID. If you spend any time with Victor, you might want to get tested or something like that. But of course it's not saying Victor, it's like 82. If you saw the number 82, you might want to go check this out. The problem with that, obviously, it relies on, first of all, the people having the actual like thing on their app, their phone and everything like that. But the other thing too is, like you said, Alvaro, is that it relies on the person looking up at the billboard and getting the notification on their phone, essentially, oh, I was exposed, to actually do something about it. But at least then,
because when you started talking about it, I'm like, oh, and then they're going to follow you around. They're going to know whose phone it was, and then they're going to say, oh, we can follow these phones around and we'll know who.
Yeah. And that's actually like a legit, like, reaction to this. And I think it's legit, like, say, hey, like, could this be used for other purposes and stuff like this? And that's where, like, the idea there, assuming that you open up this protocol to show, like, hey, this is actually, doing the things that it's saying and stuff like this, versus like, you could install an app and it says, oh, I don't take location, but it is, that's a kind of different story. But assuming that it's like, oh, it's not doing this, the algorithm itself doesn't rely on knowing where someone is or who that unique identifier is. It can be just like, oh, this is just information that can be available for other people. Anyway, this is the kind of stuff, like I'm saying, like privacy in general. I think you are going to see more and more things like this, where it's really thinking about, like, saying, oh, not just like, oh, let's just share data everywhere. It's going to be much more like, how can we share data privately but still make it useful and safe? Jessica, I saw your hand kind of.
Yeah, I was just gonna say, when I worked for like this health food startup, I would visit a lot of our accounts, which were like Whole Foods, and I'd want to see if they were busy or not. And so I would just go on Google and look up the store, and it would give me the historic foot traffic and the live foot traffic. And it's already, because it's like Google's pinging everybody's cell phones.
Right. And the thing about that too is that in that case, Google, and in some cases actually Apple does this too, right? Because basically the location services, it's actually knowing exactly what phone is giving what information. And so that's one of the issues, like, oh, it's super useful. Like, for example, like I like using, for example, this coffee place. I'm like, ooh, like, is it busy right now? Or has it been busy usually? And like, I like looking at that information. But the way they got that information is like, oh, the way they wrote it is it relies on sending this information that this specific phone was at this place and setting up to a central server. The idea there is using other methods, like, well, what if you didn't give the specific phone? Could you somehow get this information still without having to rely on some personal information, or not even personal information, but information tying to an individual? And that's, again, like where differential privacy kind of comes in, concepts like that. Yeah, I'm pretty sure you guys can all think of, like, dream up a bunch of ways like this could be super useful, where like, hey, like maybe you don't want to know information, like you don't want to be able to put that information out there, but still actually have aggregation of information together, which, again, like the 2020 census, actually using differential privacy. So if you guys do check out that video, I think it's super useful too, because it kind of says, oh, like what that would look like. But yeah, yeah, I love using these like little useful data stuff too, like you saying, Jessica, with like saying, oh, the foot traffic and stuff, because it's like, oh, good. Like, I don't know if anyone's ever done this before, but like Google Maps has it. I don't know if anyone else does it, but like I know Google Maps
Google
does.
Maps, that's what I would use. Yeah,
it's the best. It's like I can see like the live time too, like in pink. It's like, oh, like it's busier than normal. I'm like, oh, cool. Like I want to not go there right now. Like, oh, it's not busy. I'm like, oh, cool. I can go right there. I'm not a huge people person, especially during COVID. So that's kind of what my reaction is. But yeah, anyway, that's something like going along lines like, oh, things to learn and stuff like that. I think privacy, keeping privacy, like differential privacy, federated learning, things like that. I think that's going to become a lot more common, and probably another skill that's going to happen in the next, like, I would say that probably the next 5 years, I wouldn't be surprised to see more things like that. So keep it out there. Yeah, so cool. I know we kind of go on tangents and stuff like that, but hopefully you guys find that useful too. Be exposed to that and see what's out there. But yeah, any other questions you guys want to talk about, or otherwise I'll kind of show you a little bit about, I think we talked about Colab. I can show that really briefly. I think you guys know most of Colab, but it's useful reiterating. Yeah, Jessica, go ahead.
Okay, and I think the question I'd had last time is after Colab, but with large data sets. And what I realized too is that my file is on iCloud. And so what happens on my computer is like, it keeps just sending it to iCloud instead of it being like on my computer. So that's what was happening. And yeah, so then every time I get add all, I have to make sure that I click like the little cloud thing to make sure it's on my computer.
Right. Okay. So like that was the issue that it kept getting added when you do like get add all, get add dot, right? Like,
and sometimes it'd be there and sometimes it wouldn't, because like the cloud kept like, I don't know, removing it from my computer.
Yeah. So okay, I'm gonna show you guys something where gitignore. So have we talked about gitignore? I think some people might know, be familiar. So you can see real quickly, like this is the Git repo I use for the stuff we talk about, and you can see if I do git status, there's a whole bunch of changes. Like that's just me messing around and stuff like that. So ignore that. But if I do ls-la, you'll see we got a .git folder, and that's the thing that actually holds your history. Say, hey, this is a Git repo. This .gitignore here, you'll notice, is a file you can add, and Git actually looks for this specific file name, saying, hey, what's in .gitignore? And just kind of showing you guys really quickly what this looks like. You can actually add in specific file names. And so note this is a comment right here. And basically it'll look for this file name and says, hey, ignore any files that are named like this. And so this can be super useful. For example, let's say you have a big data set. I generally add this in my data. You might actually go ahead and add like data, caps lock, data like this. And that will now ignore any file, like ignore the folder data and then anything that's in that data. So if I go, let's see if I show you guys what that would look like. If I do git status, again, you'll see this huge list of stuff. So you can see here like all these different stuff. But let's say like all these project stuff, like, oh, I want to ignore this stuff. So it notes it's like, okay, this is not something I actually want to upload. It's just like my data folder. I can actually add this into my gitignore. So you would actually open up the .gitignore file. I'm just going to do some fancy command line stuff right now. So I'm just going to add it into that gitignore, the probability folder. So probability, let's find that right. Oh, sorry, not probability. I'm going to do projects. So I'm going to ignore everything like this. Okay, so I'm going to do projects like this guy. And what's going to happen now if I do git status, pay attention to how I have probability in stats and then all these things in projects. If I do this now, you actually see that projects now is no longer included on my git status. So if I do a git add, it will actually not include explicitly that thing. I couldn't actually add it, like if I want to, I can do git add projects and then add it explicitly, but it's not going to try to like add that in when I do a git add dot or something like that. So that might be a solution you might want to look at. If you have like, I like to put like my data files in data, and then I can ignore data because then it's easier for me to like work with and stuff like that. Same thing with models. If you have a very large model, you might have models and then having like that H5 file, having just ignore essentially all those files in there. So I don't have to like worry about like accidentally like having a model that's like a gigabyte large and then trying to upload my repo. I'm like, oh shoot, like I have to go back, especially if it's like, if I've done it multiple times, we're doing many commits and you're like, oh man, that was like 10 commits ago. I'm like, oh, I gotta go back in there and rebase, and it's no fun. So usually it's easier to hit those things ahead of time. Yeah, have you seen gitignore before? I might have mentioned it at least once.
I know that I use it. I think I remember, I don't know if it was in a meeting, I think Nadine asked you about it, and that's how I learned about it. So I've been using it for the past few projects.
Yeah, good. If you are looking things for like Python stuff, there's also like it's not just for Python, but there's actually different, like all these different languages, like common things that you want to ignore. So for example, here's Python. There's actually a python.gitignore file. And literally what I'll do sometimes, I'll literally just go to this like repo right here and go to python.gitignore and just literally like copy all this and I put that into my .gitignore, because then so like you can see some stuff here like you probably don't recognize, but there's probably other stuff here, like for example, IPNB checkpoints, like which like, oh, we don't need that in there, so I can add that into there and ignore Python checkpoints. So yeah, super useful, this .gitignore. Yeah, cool.
I have a question,
yeah.
quick question, and maybe you'll cover this on Colab, but one thing I noticed when I was working on the PySpark is that for some reason, every single time I loaded up Colab, it made me install PySpark, and that was like, it was so annoying, and I could not figure out how to fix that.
Yeah, so like you doing like a pip install like on Colab itself.
Yeah.
Unfortunately, I don't think, at least for, it could be different for Pro, but I don't think you can specify like, oh, like remember this thing, or like remember this like installation install or a Docker image or something. I don't think you can do that in Colab without literally just explicitly doing it yourself. I want to say there was something I saw like with the Pro subscription where you could have more access to the Docker environment and all that stuff. Mm-hmm. But to be honest, yeah, unfortunately, I think that's the best way, is essentially just doing a pip install, and that's kind of what you have, unfortunately.
Yeah, because Colab provides a standard environment for you, and that environment is that environment. Whenever it shuts down, when you go back in, you get the original environment back. So anything you added, I think you lose.
Oh, geez. So PySpark isn't like an established library that just kind of comes with the environment?
It's, the fact is because PySpark is useful in the correct situation. I know like you probably don't hear me say this too much because I've said this a few times probably in my cohort. I don't recommend using PySpark for many of the projects you guys are going to actually do, mostly because PySpark really gets its best when you're talking about a distributed network. And when you're doing Colab, you're just looking at essentially one computer. It's in the cloud, but it's one computer. And it's not really beneficial to use PySpark. So that kind of makes sense why they don't include it on their thing, because like, oh, it's another library to install, and it's not really that beneficial to use on one instance. So like, you know, I can kind of see like collabs and like other things like that. It's like, oh, there's not a reason for us to install it on here, because people who probably would be using it would either be doing it for essentially for fun to kind of test things out, or they would be using something else like an actual distributed network, which would be something like a server-based like AWS and stuff like that. So yeah, that's kind of unfortunately that's the reality.
Okay, so it wasn't just me like missing some configuration thing. I just, as a separate note, I did for, I guess it was mod 3, because I've been through the curriculum changes, being here as long as I have. And so I did the Tanzania water well classification thing. And oh my God, I wish I would have, I think, well, I don't know if the curriculum hadn't talked about Colab, or at least because it switched over around this time. I didn't really know about it, and then I didn't want to try to, learn a new system, or, try to figure out how to link all that stuff up. But boy, oh boy, I bet you it probably would have, the models would have gone a lot faster. I did a lot of different modeling and trying different things. So of course, PySpark wouldn't have been relevant, but it sounds like most of the other libraries that we would use typically, like sklearn or what do you call it? StatsProb or whatever.
Stat models?
Yeah, stat models. It's been so long since I actually used that. Yeah. So yeah. Thanks.
Yeah, no problem. Yeah, I honestly I like telling you guys early on, like, hey, Colab exists. Like, don't make your computer cry itself to sleep while it's trying to like train all your models.
Or cry while it's awake while you're asleep, because you're running the freaking models overnight, which I did more than once.
Yeah. I was messing around with something the other day, and my wife goes like your computer's getting really loud. I'm like, yeah, I know. Like, I'm getting a model in there. If you do have like a GPU and stuff like that, there might be a reason why I do that. But like, I'd say most models, like, yeah, probably don't run on your laptop. I tell people this, and people like get like, what? Like, I used to use a Chromebook exclusively for my laptop usage, which if anyone knows about Chromebooks are super like not like powerful. Like I think mine had 2 gigabytes of RAM. It was an i3 processor. And it's just like, people are like, how did you do data science in there? I'm like, because I use the cloud. Like that was easier to just do than, I also had a desktop too, but I would just SSH, like remote into my desktop and run models through there and stuff like that, which had a GPU. But like, yeah, I'm like, I don't like, at this point, I'm like looking at a new laptop possibly. I'm like, I don't need a powerful laptop because I have something that's more powerful, either my desktop or really like the cloud essentially, which can be, you know, AWS, GCP, or, you know, Colab or Kaggle kernels. Yeah, but yeah, for the record, PySpark, for the projects, I don't recommend doing it just because, unless you really want to, it's not gonna really give you any speed advantage. And to be honest, like, if I'm being perfectly upfront, like even if someone says, oh, knowing PySpark is like a job requirement, and again, of course, job requirements are more like wish lists, but if you see PySpark on there, I'll be frank, I don't think, like, I think most people starting into like data science are not going to be familiar enough with PySpark without using it on big data. And it's kind of like, so you could practice it and you can say, oh, like I tell people, it's like, if you go in an interview and they say, oh, what do you know about PySpark? Like the most that you really need to do, and this is this is kind of like my advice, my opinion, like I'm sure other people would think differently, but the most you really have to say is like, oh, I've touched PySpark, I'm kind of familiar with how this works, but I haven't done too much on big data. And I think that would be more than sufficient for most interviews. Being like, yeah, okay, that makes sense, because of course you haven't done big data, because like, what would you have done big data on? You're gonna have your own server and like, you know, like spin up like large amounts like that. It's not very common, versus like the whole process of it. It's like the process of data science is gonna be more important than you using specifically like PySpark or whatever. So that's my little advice. But cool. All right, so I realize we're like kind of going through time, but this is good if you guys have more questions. Do you guys have anything else, follow up or questions you guys want to do? Otherwise, I can kind of briefly show you a little bit of Colab, since I think we've seen it before. Then I can show you guys Kaggle kernels. Yeah. Cool. All right, so let's go check out Colab, right? So hopefully you guys know colab.research.google. Colab is owned by Google. It's changed iterations and stuff like this. I've learned a few things that, like, for example, I didn't know a pro subscription actually existed until relatively recently, which is pretty cool. What's really nice too is that Colab actually has like examples in here, and you can actually pull up stuff. For example, like if you want external data, like you can actually check out different things. BigQuery is, again, it's good Google products, so they kind of push their own Google stuff, right? BigQuery is kind of like Redshift for AWS, or sorry, AWS's Redshift is like Google Cloud Platform's BigQuery, which is what this is. So basically a data warehouse. So like they have a whole bunch of different things, like how you can do different stuff in Google Colab. But we'll just kind of pull up. I think I had one where it's your traffic sign classifier. Maybe that's what I had. We'll pull up a little thing here. The main stuff you have to know is, first of all, just the whole interface. It's basically a Jupyter notebook, just a little bit different. Because it's in the browser like this, the keyboard shortcuts, if anyone use keyboard shortcuts a lot in like Jupyter notebooks and stuff, some nods. It's kind of useful as you kind of get used to it and stuff like this. But if you do use a keyboard shortcut, they kind of change a little bit. The main thing is basically if you do Control or Command M, and then whatever like the keyboard shortcut is, like you normally would do. That's generally kind of how you go from Jupyter Notebook to Colab if you're used to using this shortcuts. But other than that, it's pretty much the same like kind of format and stuff. The biggest thing is that you are basically on a computer, or sorry, on a cloud computer. And so you can actually upload, like, you know, for example, you can upload your notebook. You can actually open a notebook from like, you know, GitHub itself. So you actually can take like, you know, your specific notebooks you have in here and actually open them up in here, which is super useful if you already are uploading it onto GitHub. You can also just like, you know, have, once you make a collab, you can actually kind of pull it up already. You don't have to like re-go this, because it's kind of like in your Google Drive. So once you have this, we actually have to connect it to basically something to run the code that's on here. So the way we can do that essentially is on this side right here, this connect, you can just go and connect to hosted runtime. If you just click connect, that will work. But it's going to show you hosted runtime versus local runtime. Local runtime, know when you say local, that just means like your own computer. So you generally want to use a hosted runtime unless you want specifically your own computer to run it because you have a GPU or whatever. I don't know too many people who use Colab for that. I think most people use a hosted runtime. So you actually click hosted runtime here, and that'll connect it to, on the cloud, basically something that you can process it. So one thing to note that though, is that when I connect here, not by default, the runtime type is going to be different. So I have a GPU already here, but by default it'll be none, which basically means just like most people's laptops, like it's a decent computer, but no GPU. You can then connect something like a GPU, for example, and that GPU, you can then use something like TensorFlow, PyTorch, whatever kind of thing that uses, GPUs to, what's it called? Speed up its training process, right? So it's parallelizable and does better tensor multiplication. There's also something called a TPU. Have you guys heard of TPUs before? I don't know if I meant to. All right, I see some head nods. I see a little kind of confused. TPU, just know like GPU is graphics processing unit. TPU is a tensor processing unit. So the thing about that is that GPUs, kind of by accident, we kind of say, hey, we can do some pretty cool matrix multiplication on here, which means we can actually do neural networks pretty fast, right? Things like that. That's what GPUs are. TPUs are optimized specific towards tensor multiplication, which tensors, think matrices and stuff like that. So it can be even more efficient than a GPU. However, if you are going to use a TPU, you might want to make sure you know how to use this specifically, because the code does change a little bit and like how you want to use this. So in general, from what we've learned already in the curriculum, you probably want to use a GPU. So you can actually check this out. Let's see, make sense so far? Cool. All right. One thing to note though is that when you do connect on Colab, especially on the free version, but even the pro version, if you do end up paying like $10 a month, they don't directly limit you and saying, oh, you can't use a GPU today. It's much more saying like if you've been using a GPU or a TPU in that case more often, it will basically, well, other people need to use the GPU too, and it'll put you down as a lower priority. So the idea there is that basically someone can't just like monopolize, run a bunch of Colab, stuff, and like use up all the GPU resources. It's trying to keep track of like, okay, let me just cycle through. So if you're not planning to use GPU, like you're going to do most of the data cleaning, you're not going to do any modeling yet, I would just set this hardware accelerator to none. And then when you want to do any GPU training, then switch over to GPU. It will change the runtime, which means you might have to run the whole thing again or parts of it again. But then that, at least you're getting, okay, now I'm going to use a GPU. And that'll kind of limit your time. And you'll tend to get, because it has different GPUs that it'll connect you to, you'll tend to get better GPUs if you're not using it super often all the time. But if it just stresses you out, like, oh my gosh, I need to flip on, flip off, you can just leave it on GPU and you'd probably be fine. I've had too many people have issues. Yeah, so once you have that, you can click save, I can click connect, and if you click connect now, it'll connect to a GPU. You can see this connecting, going through, and then it'll go through to, there it goes, it's RAM and disk. So you can actually see, it's really small writing on a little hover. We can actually see this RAM is saying 0.8 gigabytes out of 12.7 gigabytes. So I have about a 13 gigabyte RAM, which means you can kind of load pretty decent memory. I think most people's laptops are about 8 gigabytes of RAM. I think that's what we kind of like suggest, though people's laptops can have up to 32, possibly even higher for desktops. So this is a pretty decent one. You can probably load a lot of data in here and not notice it. Also note the disk space is 68 in this case. That means I could actually add more data onto this specific instance. However, like I think Alvaro mentioned it earlier today, is that if you get disconnected, whether it kicks you off because after a certain amount of time, it's just like, hey, like, sorry, you haven't been doing anything, so I assume you're not going to do it anymore. It's going to kind of kick you off. You have to reconnect. If you are there and you just like disconnect, you can just reconnect. Let's say your internet goes out for a second, you can reconnect and it usually is fine. There is a hard limit though, and it's changed over time. It's something around like 9 to, oh yeah, go ahead, Alvaro.
No, I've seen little hacks for that.
Yes, for clicking the button.
Yeah, the JavaScript hack where
Yes.
it'll just click the button, keep clicking a button. Yeah.
Yes. So one thing you can do is actually open up the inspector here, and you can actually run code in JavaScript on the side here, which will actually, you can run you can look it up really easily. If you can follow directions for data science, you guys would have an easy time doing this. But basically you can run a little code that will essentially say, hey, click the button every like 30 minutes or when it changes. And that kind of keeps you connected, but there is a hard limit to about 10 to 12 hours-ish for the free version. Basically, like even if you do keep connecting and connecting, if your if you are using it for over that time, it'll say, okay, that's enough, like, and it's going to kill your runtime. So know that if you are trying to use a GPU and you're doing some really intense modeling, right, it's probably, Colab's probably not the thing you want to use. At that point, you probably want to look at something bigger like AWS, some kind of like cloud computing platform.
Question, sorry.
Yeah.
Not to jump ahead, or maybe
No.
this isn't jumping ahead. The one thing when I was using this that had me a little, well, it was like the very first time. On the very left side, you know, you see they have the folders and the this and the that. Yeah. So folder, this is where it is storing like data and stuff, or your notebook or whatever. I guess the thing I was always struggling with when using it, it's like, so where, I mean, does it saves stuff temporarily, right? I mean, it uploads the data, it's got to save it somewhere. So I presume that's the disk that it's talking about. But where it's getting the data from, I mean, obviously you can upload it from your computer, but I mean, is it going out, if you tell it Google Drive, for example, is it going out to the Google Drive? Is it automatically saving to the Google Drive? Like that interaction or that linkage is a little confusing.
Yeah, so it's more like, they call it mounting. It's essentially, you can kind of think of like your Google Drive is now like is maybe old school, like it's like a USB. Like I say that old school because like I don't have a USB port on my computer. But like, it's like when you say like, oh, when you mount a USB and you plug it into your computer and then you can access the files on there. And then if you unplug it, right, the files are still over here in my USB, but no longer accessible by the computer. That's kind of how Google Drive works here. It's kind of like, it's like a USB for this computer, but it just happens to be like, oh, it's on the cloud. I don't know if that makes sense to people, but it makes sense in my head.
It's a mapping. It maps your drive to their file system. And you know, you can move stuff back and forth from it. As long as whatever you're working on is still on your, on that drive that you mapped, it'll persist because it'll just be on your drive, right? On your Google Drive. If you move it off Google Drive, you create a directory, but it's not on Google Drive, and you move the files there, then when your session's over, whatever was there is gone. Whatever's in your Google Drive is there. Whatever if you move something, not copy it, but move it to the non-persistent storage, you're going to lose it.
That's exactly right. And this is kind of
and does
background.
It automatically save though? I mean, does it automatically, while you're working, is it periodically saving stuff? No, so you have to tell it. Okay.
Yeah, you have to say, I'm saving this in this place. But if you do that, then it's going to automatically save. So like, for example, if you say, oh, this is where it should store, for example, this is where the path for the model is. And as it goes through, it will automatically save. Essentially, it's moving stuff into the Google Drive itself. Okay. So what I mean by that is like, if I click on this guy right here, which I love that they changed this, because when I first learned about this, they didn't have this. I had to like look this up every single time to Colab. But if you click this guy right here, it actually comes this little code, which will only work on Colab, right? It's not going to work on like if you download the notebook. But if I run this guy right here, you'll see, yeah, go ahead and run it anyway. You'll see like, oh, I had to put an authentication code. But if I put an authentication code, tell you what, I think we're fine. I don't think anyone's gonna, I'm just like, I have this recorded, like, is this gonna expose any keys? I don't think so. That's fine. I'll just delete this afterwards. I don't think this will, hopefully, I don't know. Maybe I'll edit it out if it's really that big of a deal. But it authenticates this. I think it's a one time. And no, actually, you'll see over here pop up. It says now to that content drive. And I refresh this. You can see now it's a new folder. And actually, that is my Google Drive. And now I can actually put stuff in there as a folder. And anything that gets added into here is automatically saved on Google Drive. It's like saving onto your USB. So the way I kind of explain it. Yeah, makes sense? Yeah, okay, cool. But one way to do this too is like, you can also like, for example, let's see, you can use the command line. If I do touch like new.txt, this will actually, I can write files directly onto this folder, which is here, and you'll see new.txt. This will not be saved because it's not in the folder drive. But if I did something like, you know, touch drive / new.txt. Okay, this will actually, well, in this case, this is not going to work. But like, basically, if I were to write something into that file system, right, it will automatically save in my Google Drive itself. I'm not showing my Google Drive just because I have other stuff in there that you probably wouldn't want to have recorded and everything like that. But that's the idea. No, this is kind of, yeah, don't worry about that. But you probably wouldn't do it in that method. You probably would actually have like, oh, like your models save checkpoints into that specific path. Okay. So yeah, you can upload data here. You can mount your Google Drive. Another thing I like to do is I like to, like, if I have it from like a specific source, like it's like, oh, here is like the S3 bucket, or, you know, there's a zip file that I can get like a path, and like I can get that whole thing, like, you know, HTTP plus or HTTPS, you know, this long thing, blah, 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 .zip. I'll actually go ahead and grab that specifically and download it onto the file system. And that's nice because it's like, oh, I know where it is. It might take a while for it to download on here, but I kind of like that because then it means like I can give this Google or this notebook, I can run on Colab, I can run on whatever I want, and I know it works everywhere. So there's also that option too. So yeah. Does that make sense to people when I say like download it directly on here?
Yeah, no, I use something like wget, or just use the request module or something, and download it directly through your notebook.
Yeah, I think that's general. I would probably avoid using wget because if wget's not installed on that specific computer, it's going to have some issues.
But use request or URL lib or something.
Exactly. Cool. So cool. When you're done with this, then you can run the whole thing, and you can just download, for example, like you can technically save it, and you can even do things like if you have it connected with GitHub, you can actually make commits, like git commits on here, and it will show up on GitHub, which I didn't know until recently, to be honest. But you can actually download the whole, like, you know, notebook right here, and you can see. Then I can do whatever I want. I can move this into my GitHub, or sorry, my local computer. You know, I can add it to GitHub from there. I can, you know, rerun it if I wanted to, or rerun parts of it. So it's like as if someone sent me the IPN notebook, the notebook. So yeah, cool. Yeah. Any questions on this? I think that's kind of really all you need to know.
I only have one question on this whole thing. The one thing is because, you know, if we structure our Git repository in a certain way, like having notebooks, like I like to do, have a notebooks folder, and then put any number of notebooks under that folder, and then my source directory, you know, structured like that. This doesn't allow you to bring in that whole structure, does it?
No, yeah, I believe it's only the
notebook itself.
Let's try it out. Let's go. Yeah, I think you only open a notebook, like, and that's how it's associated. It's like, oh, this is a notebook, not the actual whole repo itself. So if you do have structures like that, it's like, yeah, you can't reference it easily.
Right, and that was really that was my biggest challenge ever with using this thing, is because I like to structure it a certain way. So if you structure it a certain way, then your code is a certain way, right? Because if I'm in my notebooks folder accessing functions that are in my source directory, then, you know, I have to refactor my code just to put it on Colab.
Right, and that's where, like, this is where if you are using Colab consistently, like, oh, you do it that way. But if you're not, it's like, oh, I have to make this work in this one instance to make it run. Again, there's some like, what's it called? Like, you pay for some of the things that you can't do, right? Like the fact that I don't have to worry about setting up any servers, I don't have to worry about what connections is. I just like, oh, just upload this notebook and start running it. I pay with the flexibilities. Like, I can't be as flexible. Like, oh, I want a certain structure and stuff like that. But yeah, that's definitely a real.
Right, because like on Paperspace, I can just clone the whole directory over because it's a virtual machine. Clone the whole, you know, clone over the whole project, work on it as normal, and, you know, do it all there.
Yeah, definitely. And I think,
but I gotta pay.
Yeah, the server, like actually using a server like Paperspace, AWS, and whatnot, right, is basically like literally just a computer or like a set of computers. And you can treat it like that, you know, once you kind of like get things moving and everything like that. This is going to be much more saying, oh, you can run well, in this case, a notebook. Kaggle, which I know we're kind of over, so maybe we'll talk about this. I don't want to keep you guys longer. So we can talk about it next time.
It's got its own limitations.
Yeah, well, Kaggle's kind of nice because you can string outputs together. So what you could do is, for example, have a notebook, what they call it kernels in Kaggle, but basically they're notebooks. And you can have multiple notebooks and have the input and the output. Like run the notebook, that would put out an output, and then take that output and put it into your next notebook and kind of string things along, which can be kind of useful.
Yeah,
But again,
I've seen where they have the input and output folders.
mhm. Yeah, and this is more like the output of like another notebook can be stringed over into there, and you don't have to like rerun the whole notebook because it's already been run once on Kaggle's system. Again, though, there's limitations in the flexibility, right? Like I like to say, like whatever tool you end up using kind of structures the way you think of things too. So like if you're using Colab the whole time, you're going to think of it in a very different way than if you're using something like a server, or if you're using Kaggle kernels or whatever else you're doing, or you're doing it locally. I'm someone who tries to think of like, how can I make my system general as possible for whatever I'm using? So what I'll try to do is I tend to use one big notebook, and because in a lot of ways, like a lot of my notebooks aren't so massive that they're like so big that I can't like share them individually. And I just kind of like structure my stuff in that way. In that case, Colab works really well for me. But one part you might find, for example, is like, you probably don't want to have this guy right here, like for your, like if you make your commits on GitHub and stuff like that, not because it's like bad or anything like that, just because if someone else downloads it now, this isn't going to work, or, it's not going to be specific to their system. So I do like I personally like to structure things like, oh, let me download the whole like zip file, for example, onto whatever system it is. That'll work for Kaggle, that'll work for Colab, that'll work if I'm on a different server, that'll work if I'm on a new computer. If I go to, my computer dies, which I mean, I kind of mess around with my computers a lot. My computer like does something weird. I'm like, oh shoot, I gotta go into my other computer. I can just pull it up, download this notebook and run it, and it pretty much just works right there. But again, like that does kind of take some extra thinking too. So
That's I mean, that's what I like to do too. I learned, a bit back that it's a lot better to just download your data right from the notebook instead of doing all these other things. Like you said, I can put that notebook anywhere, run it, and it'll still download the data, structure the all of the folders and everything.
Exactly. Yeah. What's nice is like, I like to say is like humans, including myself, are not reliable enough to follow directions, but computers are like notoriously good at like following directions, almost to a fault, right? Like where they'll listen to whatever you do and they'll try their best, right? So if I tell the computer, if I tell someone just run this code, I know it's just gonna, as long as they can actually run it, hopefully then like, oh, this will be the least amount of like issues, versus like, oh, if I tell someone like on a GitHub repo, it's like, oh, you have to download this and then you have to structure in this way and put the folder with this name in this place. And it's like, I've had cases where someone goes to me, I can't get it to work. And I'm like, did you read the directions? Yeah, I read it. Like, did you move the folder? What folder? Okay. Like, so that's where it's easier to just like, all right, just run this code. Like, what's it going to do? It's going to download the thing and take care of everything. Like, don't worry about it. And it also helps with, and it helps with automation stuff.
Directories is going to do everything. Yeah.
I like hands off where I can just like run the model and like walk away, have my coffee, like make a new notebook, I don't know, like just do random stuff and say, oh, look, my notebook's done. And that's one thing that's nice about also with like things like Colab too. It gives you like little, you can get this for Jupyter Notebook, by the way, little extensions that will like ping you, say, hey, execution's done, or like, oh, execution faulted or whatever, or halted. You can actually have that. So Colab has that built in, but for the record, Jupyter Notebook has something like extensions like that, where if you have something running and you're like waiting for it for like 20 minutes, and you just kind of like want to know when it's done, it gives a little notification stuff. And then of course, if you get really intense with this, which gets the exciting stuff, is you can start building up your own systems where like, oh, when this happens and this changes, then do these functions here, or do these different parts. And that's when you can start, basically, at that point, you're becoming a data engineer. But I don't know, sometimes it's useful too. Yeah. Anyway, I'm trying to think anything I should show you guys with Colab. I think we won't talk about Kaggle today, though, because I think it's useful, though. We should go talk about Kaggle because a lot of people's data sets will be Kaggle based, most likely for the capstone. It's also useful to kind of know what this tool looks like. It's a lot more flexible. Well, okay, I should say a lot more. It's more flexible in Colab, which you might find useful or you might find too intimidating, but at least you know the option, like what you can do. But I'm trying to think of anything I should show you guys for Colab. One thing you can do, manage sessions. if you have multiple stuff right here and you want to free up resources, you can actually stop, you know, like for example, you have different notebooks or whatever, you can actually stop them and you can see exactly what's being used and stuff like that. So like, oh, I don't want to use this, and you can terminate this and whatever. There's also some settings and stuff like this. These are like really basics, like they're not really that important. Like for example, there's the light setting. This is really nice, the desktop notifications like I talked about. Let's see here, I don't ever use this. Oh, you could just for GitHub. The editor, yeah, you can change it to your specific stuff. If you're using Colab a lot, you might go more into this. Miscellaneous is kind of fun. Like they just do random stuff. Like there's corgi mode and kitty mode and stuff like that. Yeah, if you're curious about this happened on April Fool's. There's corgi mode right here. And I think power is if you type fast, maybe not. There used to be something where I think if you type, as you type, it would like have little sparks and stuff like this, which I don't know. Not really important stuff, but they exist, which can be, I don't know. When you start working on a model for like 4 hours and like staring at a screen for a long time, sometimes you just need those little pick-me-ups and stuff like that. So anyway, I'm trying to think if there's anything else I should show you guys. Yeah, there's probably new stuff in here that I don't even know about. Like I said, like I don't know, is anyone, by chance, is anyone using Google Colab Pro like that? No, I've had a couple students that had started recently using it. They really liked it. I think it's actually for $10. Like I think it's $10 a month for it. It's still kind of like, to be honest, it's a little more pricey than what you necessarily need, but you can also do quite a lot with it without having ever touched a server, which could be a benefit. I've always used the free version before this Pro was fine, and I haven't had any issues and stuff like this. The biggest thing is that basically you get like longer run times, which is why here, well, most people get Pro. It's like, oh, because I can have it run longer. Like I think it's like 24 hours is how long it can run for. But for the record, if you are doing this project and it's running like more than, I would say, if you're running more than 5 hours, like you might want to think about like what you're doing and say, do I need to run this for 5 hours? You know, maybe if you're running multiple models and stuff like that, it matters. But for the most part, I think you guys can probably run everything. Like I would say at most 2 hours per model would probably be, like if you're running a model for 2 hours, that's probably the height of what you really need for any complex stuff that you guys are probably doing for your capstone. So, yeah, cool. Any last questions? No? Feel pretty good? Cool. All right, so I'll stop recording here then. And next time we will talk about Kaggle kernels.